everybody? Welcome to another video. Hope you're ready to flex those brain muscles because today we're going to solve some linear equations. So let's get right into it. Solving linear equations. So what is a linear equation? Well, it's an equation because we have an equal sign. And it's linear because all of our variables are of the first degree, meaning they're to the first power. There's no x squareds, no square root of x. Here's a good one. There's no 1 over x. There's no x cubed, right? You get the idea. Everything is to the first power. And in this video, we're dealing with one variable, so just x. You can't have two variables, three variables, but in this video, just one variable. So this is an example of a linear equation, 2x equals 6. And the instructions for these usually say something like solve for x. So what does it mean to solve for x? Well, we're looking for some number that we can substitute in for x to make this equation true. So what this means is 2 times some number equals x. We're trying to find that number, right? So you may be able to look at this and see that, oh, well, if I substitute in 3, this should work. And let's verify that that's true. 2 times 3 equals 6. So this means that 6 equals 6, and that is true. So we found our value for x that works. So when it asks solve the following linear equation for x, our solution is x equals 3. And we did that just kind of by, using our intuition. But as these examples get more complicated, you're not going to be able to do that. So we have a strategy, and that what we do is we get x by itself on one side of the equation. And how we do this is using algebra. And we do certain things. We add, multiply, divide, subtract, do these kind of things. But what we do to one side of the equation, we have to do that same thing to the other side. Must do the same thing to both sides of the equation. So let's take the same example, 2x equals 6, and let's use this method to solve for x. So since I have 2 times x equals 6, I'm trying to get rid of that 2. So 2 is being multiplied to x, so how do I reverse multiplication? I divide, right? So I divide by 2, and that's going to get rid of that x. But since I divided this side of the equal sign by 2, I have to do the same thing to the other side. Divide by 2. So these 2's will cancel. I'll be left with x, and I'll be left with x equals 6 over 2, which can be simplified to 3. X equals 3. All right, let's go ahead and do some examples. They'll get a little bit harder as the video goes on. And also just be aware that there are multiple ways to solve these. So if you solve it a different way than I do, that's perfectly okay. So let's go ahead and start. X plus 1 equals 5. So I need to get, remember our strategy, we need to get x by itself. X equals something, right? So how do I get rid of this plus 1? Well, I can minus 1, right? If I minus 1, it gets rid of that plus 1. But if I minus 1 to this side, I have to also minus 1 over here. So that gets rid of that plus 1. I'm left with x. And I'm left with x equals 5 minus 1, which is 4. Right? Not too bad. So what about this example? X divided by 7 equals 9. Well, I need to get rid of that divided by 7 part. And this is what I think of when I solve these. Whatever's being done to x, I need to reverse it, or I need to cancel it. So how do I get rid of this division? How do I reverse it or cancel it? I multiply, right? If I multiply by 7 times x over 7, then these 7's cancel each other out, right? 7 divided by 7 is 1, so these cancel. But if I do that to that left side, I have to also multiply this right side by 7. So what am I left with? X equals 9 times 7, which is 63, right? Okay, now this example, a little bit tricky. 2 equals 11 minus x, and it's only tricky because we have this minus in front of this x. So I'll show this little trick. This is the same thing as writing negative x plus 11. And the only reason you can rewrite it like this if you want to is so you can see a little bit clearer that you're going to have to subtract 11 from both sides, right? This is a positive 11. So you're going to end up subtracting 11 from both sides to get the minus x by itself. And if you could have seen that from this original part, then you do not need to rewrite it like this. It's just up to you. If this helps you, then you can do that. So if I subtract 11 from both sides, that'll get rid of this plus 11, minus 11 to both sides. So 2 minus 11 equals negative 9. And plus 11 minus 11, those cancel each other out. So I'm left with negative 9 equals negative x. So I need to solve for x, not for negative x. So how do I get from negative x to x? So I can multiply both sides by negative 1. That's how you get rid of the negative. Because if you think about it, this is like negative 1 times x. And I can just cancel that negative 1 by multiplying by negative 1 again, because a negative times a negative is a positive, right? So if I multiply both sides by negative 1, then I have 9 equals x. And another way, you could have just looked at it and thought of, oh, well, if negative x equals negative 9, then positive x must equal positive 9. And that's fine. If you thought that, that's awesome. But this is another way to do it. Multiply both sides by negative 1. So negative 8 minus w equals 4. Oh no, w, what does that mean? Well, it's just the same thing as x. It's just a variable. Nobody said we have to call it x. That's just kind of a convention. People do call it x. But you can call it whatever. Y, J, W. You can use symbols, really whatever you want. So this may come up. Negative 8 minus w equals 4. So first of all, I can rearrange it. I can rewrite it just like I did in this previous example, because we notice we have a negative in front of our variable. So if that helps, you can do it. And this can be rewritten as negative w minus 8 equals 4. And now it's a little bit clearer to see that we got to get rid of that 8, so we're going to add 8 to both sides. Plus 8, plus 8. And so now I have negative w equals 12. And if I multiply both sides by negative 1, I get w equals negative 12. Sorry about that, it's a little crooked. W equals negative 12. Alright, for this example, we have 8x over 4 equals 6. So the first thing you may think to do is multiply both sides by 4. And that would work. You can multiply both sides by 4, and then you divide both sides by 8. And that would work. You get the right answer. But there's a shorter way to do it, and that's to notice that 8 over 4 can simplify, right? 4 goes into 8 2 times. So I can cross out the 4, cross out the 8, and I'm left with 2. If my pen were right, 2. Right? So this is really like saying 2x because we simplified it. So if there's any simplifying to do, you can go ahead and do that before you do your algebra to solve for x, because a lot of times it makes it easier. That's why it's called simplifying, because it makes it simpler. So 2x equals 6. That's what that simplified to. And now we can just divide both sides by 2. Divide this by 2. These 2's cancel. That means we have to divide the right side by 2, which means x equals 3. Okay, for this example, we can't simplify, right? 3 over 7 does not get any simpler. So now we do have to multiply both sides. And I'm going to multiply both sides by negative 7 because I want to get rid of that negative 7. So if I multiply the left side by negative 7, that's a negative 7, by the way. Then I multiply the right side by negative 7. So what happens here? Negative 1 times negative 7, that's positive 7. And on the left-hand side, negative 7 and negative 7, those cancel into each other. So I'm left with 3y equals 7. Now I have 3 times y. I'm trying to get y by itself, so I need to get rid of that multiplication, so I use division. I divide both sides by 3. And I have y equals 7 over 3. Yeah, because these 3's cancel. Y equals 7 over 3. 7 over 3. All right. Next example. 5z plus 4 equals 4. So, before I do this division, dividing by 5, I want to get this 4 on the other side. Normally, before you do any dividing or multiplying to isolate the z, you get rid of all the addition and subtraction first. Try to get it down to one term, to just something times z, or something divided by z, okay? So if I subtract 4 from both sides, look what happens. These 4's cancel. I get 5z equals 4 minus 4, that's 0. So what this means is I have 5 times some number equals 0. What's the only number that works? What's the only number I can multiply 5 by to get 0? That's 0, right? But you could also divide both sides by 5, and that works too. because 0 over 5 is 0. So either way you want to think about it, z is 0. So last example, negative 9 equals negative 1 minus x all over negative 7. So same idea. This division is happening. I want to get rid of that division, so I'm going to multiply both sides by negative 7. And I guess you could have split this up technically. I think that would take you longer if you did that, but it would eventually work. Let's see, multiply both sides by negative 7. Let me make sure to get some room. Negative 7. So I have negative 7 times negative 9. That's positive 63. Negative times a negative is a positive. And this negative 7 gets rid of this negative 7 in the denominator. I can just cross those two out. So what am I left with? Negative 1 minus x. And you could rewrite this. You could flip it if that's prettier for you. Negative x minus 1. Same idea though. What am I going to do? I'm going to add 1 to both sides. Add 1. So that gets rid of this minus 1. And I'm left with negative x equals 63 plus 1. That's 64. So what's my last step is to multiply both sides by negative 1, right? I have negative x, but I want to solve for x. So multiply both sides by negative 1. I'm left with x equals negative 64. All right, that's going to be it for today. I'll make a part 2, and we'll do some more examples, get some more practice. But if you have questions, you can leave them below. If you enjoyed this video, make sure to hit like and subscribe. And until next time, keep flexing those brain muscles and keep making those brain gains.